episode we created a Tetris game from scratch. Then, a little later, we refactored this Tetris game into a two-player game. And now, I thought we could implement network play with perhaps up to 4 players. So, here we have the Tetris that we created in the two-player episode. And we need to modify this in some particular ways. For example, this Tetris loads up 2 player fields immediately. And we want to only load 1, and we want to be able to add Tetris fields as we go. So first I'm going to show you how this Tetris works, because I have deployed it here on pomle.com, I think, tetris.pomle.com. So when you enter this, you get an ID here. This ID creates a room that other can jump into. So demonstrating it with a multi-window layout like this. So here, this actually created this room here now. And if I go to another browser, it will connect to that room. And you can see that we have a white rectangle outline in this. So that shows you what player you are. So here I'm controlling the right one, and here I'm controlling the left one. But both players see each other. And for every new connector, there is a new instance created. So this is what I'm going to build. So therefore we need to add some features here. We want to be able to add new Tetris instances on demand, and we want to be able to remove them when a player disconnects. So keep that in mind, and let's get started. The first thing I'm going to do is actually some maintenance. And the first thing I'm going to fix is a bug that we left in the last episode. So I'm going to say here, this tetris.updateScore with this.score, because I accidentally left this global function called here. And I also want to clean up the main function and move create piece into the player class. So I'm going to cut this text out, go to the player class, cut it in here, paste it in, of course. There we go. And then instead of calling global create piece, we call the scoped create piece method here. So we do these two things, and then we make sure that we didn't break anything, and we have a little bit of a cleaner environment. Another thing I want to mention is that I have a console up here. So here I'm running Ubuntu in Windows using WSL, that is the Windows subsystem for Linux. So this is an Ubuntu environment running in Windows, but this will work equally well with anything that supports NPM. So the first thing I want to change in my code is to move from this strict initialization in the main method to something that can handle the setup of the players. So I'm going to create a new class, and I'm going to name this the Tetris Manager. Class Tetris Manager. And the constructor takes an instance of the document. So fix some spelling here. Strong constructor. And it stores the document as a property on itself. Document. And it should keep track of the instances that it creates. So let's save this now here as Tetris Manager.js. Here I iterate over all the player elements in the index.html. And we're gonna do that for now, just to maintain the functionality. So I'm cutting this out, and I'm writing const Tetris Manager equals new Tetris Manager with the document as argument, and a big T there. And I also want to say Tetris Manager.instances index.player here, so that we can talk to the correct thing when I click a key or type a key on the keyboard. I'm saving this now. Go back into the Tetris Manager, and then I'm pasting in what I copied out. So we remove this tetri array because we don't need that, and we replace it with this.instances here. So we should have maintained functionality now, just with a little bit of refactoring in it. But we only got one player. Is that because I deleted one of the indexes? No, we didn't. So I'm running the right code, or what's going on now? Oh yeah, I'm running the online version. So we're going file. Where is this thing? Tetris network multiplayer. There we go. So this is the local code. But so far the refactoring didn't do anything for our functionality. So let's do a fun change now. I want to be able to add and delete these on demand. So that means I want to start with none, and I want to add one for the local player, and then whenever somebody connects, I want to add a new one, and when somebody disconnects, I want to remove one. The first thing I do is go into the index.html, and then I delete one of these player elements, and I'm going to wrap the first one in a template tag. And this template tag will have ID player template. Oh, it's a little bit noisy. I'm gonna close the window. So, what this means to have it wrapped in a template class is that nothing inside it will be accessible by the browser before it has been imported into the document. So I save this, and then I want to demonstrate that this is true by putting a console.log here. Since we look for the .player class here, or the player class, and it is wrapped inside a template, it will not find it. It can find the template tag itself, but everything in it is inaccessible before it is imported. So there will be no player elements here. And voila! Nothing happened. Perfect. So now instead we want to have this on demand. So when I run a method on the Tetris manager, it should create a Tetris. So I'm first going to access the template here. This.template equals document.getElement by ID. And it was the player template we want. Then down here, I create a new method, createPlayer, and it wants to access the element of the template. So const element equals document, this.document.import node, and the node is in the templates, so this.template.content. And let's look what this looks like. Console.log element. I'm gonna call this initially from main. Tetris manner.createPlayer. Here we got out a document fragment. And this is not accessible by itself, like this is still the wrapper even though the template is a wrapper. So the document fragment is kind of its own entity inside the template that is not actually the element. So the way to solve this in this case, I think, is just to access the first child. So a slight cleanup here, put a new row and then .children and the first. Now we should see a player element here. Oh no, we didn't, because I forgot to do a deep import. There we go. Here we got a new instance of the player element that we can then launch into the DOM again. But we're gonna do with this element what we did up here. So I'm gonna copy this here. We supply the newly created element with the Tetris game. We push the instance on the instances array, and then we want to reveal it in the DOM. So we say this.document.body.append child element. This will put the new Tetris game in the end of the DOM. Actually, we're gonna call this Tetris.element here because this class exposes the element as a property, and I think it's a little bit nicer and consistent to do it like this. And lastly, I want to return this instance of Tetris. Return Tetris. So let's see if we are creating a new Tetris now. We are. Beautiful. And I also want to see if we can create a bunch of new Tetrises. Tetris manager.createPlayer. And we can. Perfect. And now we want to be able to delete them as well. So I'm saying remove player, and we take an instance of Tetris. And first we should remove it from the array. But I think arrays are not necessarily optimal for this work, so I'm going to make the instances into a set instead. New set. And instead here we say instances.add. And then because we have a set, we can utilize this.instances.delete Tetris. And afterwards we want to remove the child from the body. This document.body.append child should be remove child. So let's see if we can utilize this. Refresh, and we say const t as Tetris equals Tetris manager.createPlayer. Boom, it's there. And now we have saved this instance in T, so we should be able to run Tetris manager.remove player and supply T, and it should take it away. Perfect. Now we can remove this code that are not longer needed. And in the main, I want to make the first player this const local Tetris equals Tetris manager.createPlayer, and we say local Tetris.player here instead. So we refresh and make sure that it works, and we have a local Tetris instance here. Now we want to connect to a server, and for that I want a new class. So I'm creating a new file, and I'm gonna save this as connection manager.js, and I write class connection manager, and it has a constructor in which we create a property that is null named this.con that will hold the connection, the WebSocket connection. Then we want a connect method, and it takes an address argument. And what this do is set up a new WebSocket with the address and saves it to this.con. New WebSocket address. There we go. And we add this file here. Connection manager. And then we want to try to connect in the main file immediately. So const connection manager equals new connection manager. And connection manager.connect. And the way to connect to a WebSocket is by the protocol WS. And then now I'm just gonna hardcode local host and port 9000 here. Now let's see what happens when you run this. Okay, we got a connection error here because we have no server to respond to this. And this server we're going to make now. So first I'm going to do a little bit of cleanup. I'm going to create a directory for our client code. I'm going to move all the JavaScript into there. I'm going to have this up when I do this so you can see the files jump around. So here's my new folder that I created. And then I move the JavaScript mv star.js to client. And then we should update our index file here. And we make sure we didn't break anything. So the Tetris works, we still cannot connect. But we're going to create a new file that will be our server. So I'm gonna create a new folder here that is server. And in this I'm gonna write main.js. That will be the name. So now we have a server here with a main.js and a client with a main.js. So these are the entry points of our programs. And the first thing I'm going to do in the server is require the WebSocket server lib. So const WebSocket server equals require ws.server. And now I need to install this package. So I can say npm install ws. There we go. And with that package, I want to set up the new server and listen to port 9000. So I say const server equals new WebSocket server. And the arguments is an object here that says port 9000. So if I go back here and run this with node server/main, should see nothing, but the browser should not complain anymore. So this suggests that it's actually connected. But we probably want some more feedback on that. So we're gonna add some connection listeners here. We say server.on connection. We will get a connection out here as an argument. And we simply log this as console.log connection established. And once we have the connection here, we can listen to this and say con.on close. Takes no arguments as far as I know. And we simply say console.log connection closed here. Let me resize this window a little bit so we can see what's going on in both the server and the client side. They restart the server here now to load our updated code. Here we go, connection established. And if I close that old window, it closed. So now I want to send our first message. So we open up the connection manager here. And I'm going to add an event listener here that is called the open event. This.con.add event listener open. So this just calls, so this gets called once the connection has been established. So we say console.log connection established. And this is of course on the client side this code is running. And we say here this.con.send create session. So this is a request from the client side to create a room on the server. On the server we need to handle this message. So once the connection has been opened, we say con.on message. And we get the message out here. And we can just log this. Message. Massage received. This is the message. So we save this. We restart our server. And we load our website. And we see here that we got the create session message. So here on the server now, I want to keep track of all the sessions that have been created. So I need a sessions variable. Const sessions equals new map, because that's what where we're going to store sessions in a map. Then I want a session class to help us with some things. So I say class session. Oh, bad autocorrect. And the constructor, I wanted to take an ID here. This.id equals ID. And down here, we want to detect what the message is. So we say if message equals create session. Then we say const session equals new session. We name this foobar. And we add this session to the map. Sessions.set session.id and session. And let's log this out here. Console.log sessions. We restart our server once again. We connect and see what happens. So you see the server got the create session message and it added a session to the map, the sessions map, with ID here and the session here. But I want to show one thing here. I scroll down a little bit And every time I create a new connection, we get a new session with the same name. This isn't really ideal because we need to be able to create multiple different rooms. So I'm going back to the server here and I'm going to create a little helper function. Function create ID. And it takes the length argument, how long the ID should be, and I default to 6. And it takes the shards that it can be made up of. And I'm just gonna go with lowercase a, b, c, d, e, f, g, h, i, j, k, l, m, n, o, p, q, r, s, t, u, v, w, x, y, z. And then I usually remove v and u and I and l, because I think those characters are confusing. And then I'm gonna add numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's our pool of characters that we allow IDs to be created of. Then here we instantiate a string, let ID equals empty string. Then we while loop over the length and just say len minus minus. And for every time we still have length, we just plus one character onto the ID and say ID plus equals chars math.random times chars.length, and we floor it. Then in the end we return the ID. Down here we create this new ID here by saying const ID create ID, and then the session here gets this ID. So once again we restart our server, clear, and we make a new connection. You see we got a random ID here. Create a new one. Now we have 2. Now we have 3 sessions. We have 4 sessions. And this will of course go on and on. So we should clean this up. This means that I want to keep track of the clients that connect. So I'm going to create one new function. So I'm going to create a new class for the client. Class client. And the client has a constructor and it takes a connection. The same connection as we get here when a connection is established. We say this.con equals con and this.session equals null. So the session is the session the client will live in. Then down here on connection we say const client equals new client and we supply the connection. And we want to join a session. So once we create a new session, we want to join it of course. So we can say here session.join and the client joins. So we need to specify how this works up here. So we create a new method here that we call join, and it takes a client. And I want to make sure first a little sanity check that the client isn't already in a session. So if client.session, that means that it's already set. We throw a new error that says client already in session. And this is to expose bugs early. Then if this wasn't true, we didn't throw an exception. We can say this.clients.add and we add the client. And this.clients is a set on the session. This.client equals new set. And then we say client.session equals this. We should also have a leave method that is fairly similar but does the opposite thing. We say leave client, and this checks for the opposite of having a session. If client.session not equals this, then we say throw new error, client not in session. But if it is, say this.clients.delete client and client.session equals null. We save that, and down here in our connection handler we have the join already, but on close we want to leave. So when a connection is closed, we want to get the session out. So we say const session equals client.session. And then if we have a session, if session, then we say session.leave and the client leaves it. Then if session.clients.size equals 0, that means that there are no more connections or clients in this session, or room we could call it. Then we delete the whole session from the sessions map. Sessions.delete and session.id. So back to the server, be clear and restart. And we connect and see what happens. There we go, new session. And if I refresh again, connection closed, message received, create session. And you can see here that it actually deleted the old session when the last client left. But now this server file here is getting a little bit cluttered, so we're gonna clean this up. So I'm gonna put this session in a new file. So I cut this out. And I create a new file that I save in the server dir. So Tetris server, and I call this session.js. Paste this code in, and in the bottom I write module.exports equals session. And I include this in the main class. And I want to include it here, I think. Const session equals require dot session. And I want to do the same thing with the client. So I cut it out, create a new file that I save as client.js, paste it in, module.export client, and here in the main I want to include it. So let's make sure we didn't break anything. We restart our server. Seem to be okay. In the client, I want to add a method to send messages back to the client or back to the browser. So I'm going to call this method send, and it's going to take a message. And I want the console log here when we're sending a message. Console.log sending message. We actually can do this by templating strings or whatever it's called. Message. Whoopsie daisy. And then we say this.con.send message. And here I'm going to send in a callback that I call ack. And it gets an error. So that if we send a message and it doesn't work, this callback fires with an error. And I want to console.error it. Message failed. And I say message and error. So that I get some feedback on that we couldn't send a message back to a user. And the thing I want to send back on connection is the session ID. I'm going to remove this session logger here. And when we have connected to a session, I want to send client.send session.id. And on the client side, I want to receive this message. So I create a new event listener. This.con.add event listener. And with this is called message. And we get an event back here. And this event contains a data property. So you can see that these WebSocket things are not exactly the same, but they're very similar. So console.log received message and event.data. So we restart our server. And we connect and see what happens. Oh, it broke. Okay, I spelled constructor wrong. Constructor. Okay, that's unfortunate. Let's try this again. Kill this. Do it again. Refresh. There we go. So we're sending the message back. Let's see if we can see that in the console here. Whoops, daisy. Here we go. Message received. And the sent message was the same received. So we have some integrity here, I feel. But right now we're sending only strings. And that can be a little bit tricky to deal with because it's hard to separate the data and the type of message. So I'm going to do a little bit of refactoring and send all the messages as JSON. So first I want to add in the connection manager a send function. So send, and it takes some data and it converts this to JSON. Const message equals JSON dot stringify data, and we log this console.log sending message $message, and then we say this.con.send message. And now instead of saying this.con.send up here, we're gonna pass an object into the send method, and the type of message will be now we create session, and we have no data. So this will just be a message with the type. We save this, and then we want to do the same thing in the client. I'm actually gonna copy this out and bring it back in here so you see. Well, actually everything we need to do here is just name this data and we stringify it. There we go. And in our server we need to now parse this. So down here we can say const data equals json.parse message. And now of course we need to check that data.type. We also, when we send this back, we need to apply an object to the send method. So here we say type. The message is a session created message. And the ID is the session.id. So save this. And we want to try this again. We start the server. And try to reconnect. So here we got the message received was type create session, and then we sent the message session created and the ID b3dati. And here we can see how we receive this message. Now back to the code, and on the client in the connection manager I want to handle a received message. So I'm gonna add a new method here that's called receive. Not sure how to spell that, but I think that's close enough. And we receive a message, and we unpack this into the data, just as on the server. JSON.parse message. And here we want to say if data.type equals session created, then we want to set the window hash to the ID. So window.location.hash equals data.id. And up here in the message received, we want to say this.receive, and we say event.data. So now let's see if this works. And we should get a hash after here when we refresh. And we do. So it got the message and it updated the browser state with the session created on the server. Since some peers are creating sessions or some are joining them, I want to handle this nicely. We're gonna create an init session method here. And what it's gonna try to do is see if we have a hash when we start the browser. So const session ID equals window.location.hash.split, and we split on the hash and take the second part. So that means that we get everything after the hash. Then if we have a session ID, then we want to join the session. So we say this.send type join session, and ID is the session ID. Else we do the thing we did up here. We move this down. Save the init session method. And then we just simply call this up here on when we have connection established. And on the server, we need to handle this. So we create a new if statement here, else if data.type equals join session. Then we get the session from the sessions map, const session equals sessions.get, and we should have the session ID in the data.id, and then we join this session.join client. And down here I want to log out the sessions again. So console.log sessions and the sessions. So restart, and then we want to remove this current ID so we don't join anything. And here we go. We create a new session and we have it here, and we have one client in the clients. So if I create a new tab here now, you see that we got a join session message, and we have now 2 clients in this sessions clients list. But what happens if I try to join a session that doesn't exist? So let's say I write this method session here. I need to refresh the browser. Okay, so we exploded here. That's not very nice. I think that we should handle so that we can create custom rooms. So in order to do that, we go back to the server. And I'm gonna refactor a little bit. I'm gonna create a function to handle the creation of the session. Function create session. And we take an ID here that defaults to a random create ID. So basically this says that if we get an ID, use that ID, otherwise run the create ID function and use that. And if sessions.has ID, then we throw new error, and it says session $ID already exists. A little bit of sanity checking there. Otherwise, we create a new session. So const session equals new session with the supplied ID. And we log this out, console.log creating session. We print it. Then we say sessions.set the ID and session to create to put the session in our sessions collection, and then we return this new session. I also want a get session function. So say function get session ID, and it simply tries to return existing session. Return sessions.get ID. So this get session is just this thing down here. But if we try to join a session and it doesn't exist, we could create it with the data.id. So down here we can say get session, supply the data.id, and if that doesn't exist, we create it. Data.id. And we can just join it after that. And up here we can now simply create a new session with our helper function, create session. And since the ID is created implicitly when it's not supplied, we don't have to supply it here. and the sessions.set already exists up in the create session method. So this is taken care of there. So now let's say if we have prevented our brokenness, we start our server, and now we're gonna try to join a non-existing channel. So it looked good. It joined the method channel, and if I try to join this in another window here, we join this as well. And if both exit, this should be collected. That means that if I join a new method now, if I join a new room now, room 1, we see that we only have one room here because the method room was cleaned up when no clients were connected. So now I want to prepare for being able to send messages about clients to the browser. And I want to add IDs to clients. So we go first into our client file here, and we want to say ID here so that we can identify them. And I'm going to add this as property here. Then in our main method, I'm going to create a new function called createClient, which take a connection and defaults to a random ID. And this simply returns a new client with connection ID set. New client, connection and ID. And we use this down here instead. Since the ID argument is optional and defaults to random ID, we don't have to supply it down here. And when a client connects, I want to broadcast this information out to all the connected clients. So here I create a new helper function that I call function broadcast session, and it takes a session as argument. And first I want to get a list of all the clients out as an array. So I can say const clients equals, and we use a spread operator on the session.clients set. Then I want to iterate over the clients and say clients.for each. I get the client out. And then I say client.send, and I send a session broadcast message type session broadcast. And we send information about the peers that are connected. So we say peers, and we have a new object here. And here we write u, which is the client.id. So the one that is currently receiving the message knows who is you. And then we send a list of all the clients. We say clients, and we can say clients.map client and client.id. So this clients.map, it iterates over all the clients here and returns only the ID part, because that's all we need to send to the clients. It knows the amount, the order, and the ID of them. Then down here in join, we just run broadcast session with the session that we created or got. So back here, we restart the server, load out the browser. Let's open this so we can see what we get. Do a connection. And here we got the session broadcast message. You can see that my ID is ES6006, and the clients that exist is only me. If we connect to a new room here, or connect with a new client, we can see that we got a new broadcast message, so that I'm still ES6006, but now we have a new client connected. And if I disconnect here, we should get a new session broadcast that tells us that this player is no longer here. So we need to call broadcast session on connection close as well. So all we should have to do here is, after we have checked if the session was empty, we have to run broadcast session with the session that was left. So let's make sure this works. So we start a server, run a Tetris here, created a room, join another player, and we clear the log here to make sure we can see it when I disconnect. Boink. Yeah, we got an updated message that we're alone again. So now I want to handle the session broadcast message in the connection manager. So we're back to the editor, go to the connection manager, and the first thing I want to add is keep a list of all the peers. This.peers equals new map. And then I want to talk to the Tetris manager when things happen with the session. So I'm going to supply the Tetris manager here up in the constructor and keep an instance of it here as a property. This.Tetris manager equals Tetris manager. Then I want to receive this message. So if data.type equals broadcast, session broadcast it is. Session broadcast. Then I want to update the manager. So I say this.update manager, and I supply the data.peers. And the data.peers is of course this property here with the U and the clients. Like this thing is what to supply. And we implement the update manager up here. Say update manager. And we receive the peers. And first I want to know who is me. Say const me equals peers.u. And then I want to filter out myself from the clients because I don't need to create myself. So const clients equals peers.clients.filter. And we get IDs here, and I just simply filter out when me are not ID. So it means that all the clients where the ID is not matching myself gets removed here. And then for clients.for each, and we get an ID out here. We want to check if we already know about it. So we say if not this.peers.has ID, and that's the map of peers that we have just initialized in the constructor. Then we create a new Tetris. So const Tetris equals this.Tetris manager.create player. Then we associate this player with the ID. This.peers.set ID and Tetris. And now in we go to our client main method. We need to supply the Tetris manager here in the constructor of the connection manager. So let's see if we have any luck with this. Let's refresh. I'm gonna make this window a little bit bigger. And then I connect here in a new tab. Boom. There we go. So this created a new instance of the Tetris when we connected. And now I disconnect. And nothing happened because we don't handle the disconnect message. We just create new Tetris instances if we need to, and we never delete them. So the way to do that is we can convert the peers entries to an array. So we say this.peers.entries. So now we have a pair of IDs and Tetris instances in an array that we for each over, so just for each. And we want to spread that to ID and Tetris because we got a pair here. We can just put that into variables, so it's a little bit nicer to work with. So now we're iterating over all the peers we have saved. If any of the things that we have on screen is not in the broadcast message, we can delete it. If clients.indexOf ID equals -1, that means that array does not contain this ID. we say this.tetrismanager.removePlayer Tetris, and we delete this from the peers map. This.peers.delete ID. So let's see if this works for us. Create a new instance here, and we connect another user. We have two, and now we disconnect one of them, and we can see that it was cleaned up. Seems as more things happened actually. Well, let's see if this is a bug. We have two, and we disconnect. Now it seems fine. One more nice to have thing is to mark the local player. So I'm gonna go to our index.html here, and I'm gonna add a CSS rule that is player.localCanvas, and it is gonna have a white border color. Border color white. But the default border color will be a little grayish. And then in our client main, I simply want to set this class on the local Tetris. So local Tetris .element.classList.add, and we just add a class local. Let's connect to this. It's a bit gray, so you can see, oh, this is me and this is somebody else. So now we have one strange thing happening, and it's that these are not sending, like this game is now running locally. Like the second player is set up just as if it's just updating normally, and this shouldn't update unless we get a signal from the server. So we're gonna turn off the auto update from a Tetris game. We go in here to the Tetris client Tetris. And then we're gonna do some refactoring of the update method here. We're gonna rename it to this.update. This.update. And we're not gonna run it by default. Instead, we're gonna have a run method here, so that we can say outside of the Tetris game if it should activate automatic updating or not. So this.update. And now in a client main, we need to run the local Tetris. This means when we do like this, and we have two players, the local player is simulating and playing, but the second they're connected, nothing is happening to this unless it gets a message from the server. So now we want some way to know that the player has moved. And I don't want to couple this hard with the player class. So we're gonna add a little event library. I'm gonna close down the server parts for a while, and I have a new file here. So I create an event library that's called events, class events. Then it has a constructor. Oh, I don't want to spell this wrong again. And here we have a listeners set. Plus new set. And then we can listen for a name, and we supply a callback. This dot listeners dot add, and I add an object here with name and callback as properties. And I also want to be able to emit. So I emit name and data. And this dot listeners dot for each listener. And if listener dot name equals the supplied name, we call the callback with the data. Listener dot callback with the data. Let's save this, and we save it as events.js. And The reason I put ... data here is because this is like, I think it is called the rest operator. So we get the name as a named argument, then it just says here, put all the rest of the arguments in the data variable as an array. And then I can simply spread this here with the same operator. So I call this callback with all the arguments spread out as an array. So this is the same as writing data 0, data 1, data 2, except that it is dynamic. So I don't have to keep track of anything. Now we're going to use this event library in the player. I'm going to start by doing the score fixing. So first we need to add it to our index.html. Let's put it here. Events. And then in the player, I am going to add a property here with events on it. This events equals new events. Then every time I update score, I want to emit a score event. So I search for update score. And I simply say this.events.emit score and this.score. So now I can remove this, the Tetris update score thing. And do we have any more of it? Yeah, we have an update score here as well. So we replace the Tetris.update score with that one. Then now, in our Tetris class, we can listen to this event instead of injecting Tetris in it. So here we say this.player.events.listen, and we listen for the score event, and we get the score out up here. And then we call this.update score instead with this score. So we want to make sure this works. Let's kill that session. I'm gonna say here Tetris manager dot instances dot zero dot player dot score equals 1000. Oh, it turns out I spelled listener wrong here. Where was it? Events 20. Listeners. There we go. Boom, give it 1000. Undefined. I don't have any instances. Let's fix that. Oh, yeah, I made this into a set. So we can simply say we have spread this first. Instances 0. There we got a Tetris.player.score equals 1000. And now, boom, the event worked and updated DOM. So now I want to emit events for position changes. And so we should be able to copy this out here. And then I think this is a position change event. So down here, we just emit event push and this.push as argument. And if we actually collided when we try to move and we cancel it, we can just return early here so we never end up down here in case it should be cancelled. I also want to do this in the drop method. So we can say here, this events push, because this is also when the position updated, and we return early if it was cancelled. Yeah. And then of course I want to now reset the drop counter up here. That should make sense, right? Because no matter what, if we call drop, even if it doesn't work, it should reset. Yeah, that checks out. So now I want to go back into the Tetris class here. And I'm just gonna log this for now. So we log the push event. Console.log player push changed to this. So let's make sure we can handle this. Yeah, seems to work. We got the new coordinates out every time we move. We also want to have event for matrix changes, so when we rotate or change the piece, we want an update. So we go back here to the player, and here in the rotate method, I want to do something similar. So I simply say this.events.emit matrix and this.matrix. This should also happen on reset. So I guess down here we want to update the matrix, and this also resets the position. So we're gonna emit 2 events here. And let's log this from inside our Tetris game. Here we go. We got the matrix changed when we rotate. You can't really see it now because it's the box. But let's see here. And we got to update the matrix. And also when we reset, we get matrix changed. We should also add these events to the arena, because when the arena is cleared or when an object merges, we need to send the arena updates. So we close these things that we're not using. We go into the arena and we add an events class here. This.events equals new events. And then I know that when we clear, we don't want to send a matrix update. So this.events.emit matrix and this.matrix. We should also emit this when we merge, and we should emit it when we sweep. So now we have events to listen to on the arena as well. So now here we are logging these things, and that's not what we want to do. We want to instead connect the event listeners when a player connects, or when we join the server. So I'm gonna cut this out here, and I'm gonna go into the connection manager. And here I'm gonna add a method that I call watch events. Watch events. And what this do is set up event listeners on the player and the arena. I'm gonna paste this in here now. And then I want to keep track of the local player, which is always the first one we can assume. So here I'm gonna say this.local Tetris equals Tetris manager.instances, and the first one, so we need to spread this and we take the first index. So now we can save this here, const local equals this local Tetris, and then const player equals local.player. And then here I want to iterate over all the potential events. So I just list them here. Pos, we have score, and we have matrix. So I say this array with position, matrix, and score. I for each. And here I get out a property. Then I add an event listener for that property. So I say player.events.listen for property. And I supply a callback. So when this property updated, I want to send some data. This.send type equals state update. And I'm gonna call this the fragment, which will be the player. So because I'm sending a state update for the player. And then I'm gonna say hey, down here player and the array prop, and then the player and its property. Or should we be able to maybe give the value here? Is that possible? I think it might be actually. So now we should send all the player events to the server. And we just start this at this init session and then this.watch events once the connection has been established. Let's see now what the program does. Gonna resize this window to have it to screen, because now I want to see what the server is interested in. So I close the console, tab up the server, and I'm just gonna clear this here. We connect, and then we see, yeah, every time we drop, we send a new message here. Let's remove the session logging because that's not really needed now. So we remove some clutter. So remember I put here, yeah, we log the session for every message, and that's kind of pointless now. Restart the server again, and I connect. And here we can see that we get a state update from the player with the position and its position. And it also happens when I move, and it also happens when I rotate. Here I get the new rotated matrix. And do we get the score too, even though it wasn't updated? Cool. Now let's do the same thing for the arena. So back to the connection manager. And the arena is very, very similar. I'm just gonna copy paste this. Whoops. Arena. But arena have only a matrix event, so I'm gonna remove score and position. And the fragment now is arena. We set arena here. And the value and the rest of the things should be same. So let's see if we get this event now. Refresh this game. So when I merge now, yeah, we get the state update for arena with the full matrix. And we can see here that 77, that's the color here that we get in the big matrix. And now, of course, I want to broadcast this data. Whenever I get a state update in the server, I want to send it out to all the clients. So let's close these unused files for now, and we're going to the client, and I want to add a method here called broadcast. And the difference between broadcast and send is that broadcast will send a message to all the clients that is in the same session except for myself. So first I need to check if this session, and if we don't have a session, we throw an exception. Cannot broadcast without session is the error. Then we're gonna populate the ID on the data. So we say data.clientID equals this.id, so we know who sent it. And then we just iterate over the sessions clients. We can actually do it like this. This.session.clients.for each. And here we get a client. And first we want to check that it's not ourselves. So we say if this.id, or yes, we can say if this equals client, just return. And we skip this one. Otherwise, we say client.send data. Then in our server main, we want to handle this new state update message. So we say else if data.type equals state update. Then we simply can say client.broadcast data. So just if we get a state update message, we just send this message out to all the peers. So we kill our server and relaunch it. And we go back here to our Tetris game. We launch a new one. And now when I connect a new player, we should be seeing some sending too. Everything is moving so fast now, so I'm actually gonna kill this so I can see what's going on. So here we got sending message as session broadcast, that was our killing. But here we have message received, state update, and then we sent the state update with the client ID. So now we go back to the connection manager, I think, and we need to handle this state update message too. We go down here to receive, and else if data.type equals state update, and we say this.update peer, and we can give it data.client ID. We can say data.fragment and data. Here we have a problem. We can probably just normalize this to state and go up to these and just say state here instead. Then we implement update peer here. Update peer, and we get an ID, we get the fragment, and then the state is a key value pair, so we can normalize this here to key and value. Or actually, it was property. We say that, we use that too. Then the first thing we need to check is if we know about this ID. So if not this.peers.has ID, and this.peers is of course saved up here. When we update manager, we just put all the clients in the peers map. If we don't have a peer ID, we can just console.error client does not exist ID, and we return. Otherwise, we should get the Tetris instance out from the peers map. Const Tetris equals this.peers.get ID. And then we can update the fragment with the value. So the Tetris fragment, and fragment is either arena or player, and then the property equals value. And if key equals score, property. So if the score property is what was updated, we can just say tetris.update score, and we give it value. Otherwise, we redraw tetris.draw. So let's see what we got. Zoop. Let's create two new browser windows here next to each other. Oh, hey. Network multiplayer. There we go. And the new tab, create a new Tetris here. Now we have two. And we can actually see that we are sending the updates. But it looks like we're not consistent from the start. If you see, if I refresh this, we actually have the wrong piece. And it's because we don't send the initial state. But once I have laid it down here, it stays in place. Another problem is that if I join late, I don't see the arena until the arena message has been sent. If I join this again, see that it's... oh, now I don't have an arena to show it, but let's just insert some things here to display what I mean. So if I rejoin here now, you can see that this is empty because there is no arena matrix sent before this has hit the bottom. So there, boom. So in order to fix this, we can keep a record of the game state on the server that we send on broadcast. So first I'm going in here to the Tetris.js and I'm going to create a serialize method. What this method does is return a simple representation of the state of the game. We say return, and we return an object. It contains the arena, and the arena has the matrix. And it also returns a player, and the player has a position, has a matrix, and it has score. Whoopsie daisy. So now we're gonna do multi-line editing here, and we just say this.player, copy this dot that. And that should be enough for serialize. So whenever we need a representation of the game, we can just call serialize, and it returns an object that turns into JSON very well. Let's try this out in a game. Let's remove our extra Tetris here for now. Have one. Open the console. I think can widen the window a little bit. What is it I can run exactly? Local Tetris. What is it? Tetris? I don't remember the name. Let's go into the main and see. What was it? This one. Local Tetris. Let's filter out these things. Ah. So local Tetris.serialize. Arena is not defined. That we need to fix. Yes, of course, this.arena.matrix. There we go. Here's our arena and player serializable. So just to show you how serializable it is, JSON.stringify. Whoop. There we go. And we should also have an unserialize method that does the opposite. We say unserialize, and we have a state. And here we can use the object.assign thing to fix this. So we say this.arena equals object.assign. State.arena. And for player, this.player equals object.assign state.player. And then lastly, we want to update the score. This.update score. This.player.score. And we draw. Oh, I need to, I spelled it wrong here, assign. Now we can use the serialize and unserialize in our connection manager. So here in init session, I also want to copy the state. So I say const state equal this.local Tetris.serialize. And then I provide that with the join or create message. So just give it here the state too. State. And on our server, we should save the state. So let's go into main for the server. And we find the create session handler. And after we join, we can set client.state equals data.state. And we should do the same thing for join, I think. Data.state. And I think it's good to just keep the state property here as null before we have it. So now we should send out this full state on broadcast. So in our clients.map here, we can actually return an object. I'm going to create a function here and then return an object, and it contains the ID, which is the client.id, and it contains the state, which is the client.state. There we go. So now we should be sending the full state on broadcast. Let's see if our theory checks out. It does not. We have a problem in the code. Yeah, here we need a comma because this map is actually inside the object literal. So let's start the server again. It should work. And we create it here and let's not filter it. So this is good. Here we got the join message here with we sent the state, and we got a received message here with session broadcast with the full state in. So now let's go into the connection manager here, and we need to handle this on update manager. We need to do a little bit of refactoring here to make it works. So instead of having only the ID here now, we now have an object that is a client object. And the filter here does need also to handle this. So me is not equals client.id. Then we iterate over the client, and all the places where it says ID should say client.id instead, including here. And here we know that we haven't seen this player before. So we can unserialize the state. So down here, after we created it, we say tetris.unserialize the client.state. And down here, with where we check if we need it, we can't really check the index of here. So I'm going to replace this with something that's called the sum method. We're going to say if not clients.sum, and we get the client out here, and the client.id equals id. So basically what this says, if we loop over all the clients and we can't find anyone that has the same ID as this one that we loop over, that means that this was not in the payload, so we can remove it. We also need to remember to update the server state whenever a player sends a request for it. So let's go into the server here, and on state update, just write the change to the client. So const key and value, or let me keep this consistent, prop value equals data.state, and then we write it to client.state data.fragment and prop equals value. So we set the initial state on the client, and then for each update we get, we keep this value on the server as well. So whenever we do broadcast session, we always have an updated copy of the player state. So let's see if we can make this work now. I'm gonna put this window to the right. I'm gonna create a new one here, and I'm putting that to the left. Obviously it was the opposite, but who cares? And when I enter here, I should have seen this on the bottom, but it didn't work, of course, for some strange reason. And why is that? Is it because I'm an idiot again or something? Why don't I know how to code all of a sudden? Yeah, I forgot to restart the server. That's how much of an idiot I am. So we connect here. Have a bunch of data. Or the Tetris. There we go. So we saw the data here when we logged in. And do we get an updated state? Boom, we do. We get the first state from the server. So that looks nice. Now we just need to add a support for one more thing, and that is sorting. So we're going to have that in the connection manager. And here we already have our local Tetris instance. So in our update manager, we should be able to get all the Tetris instances in the correct order according to the peers payload. So I should be able to say const sorted equals peers.clients.map. I get the client in here, and I map this to this.peers.get client.id, and if I don't find it, I default to this.local Tetris. That got a little bit long, so I'm actually gonna split that up into 2 lines. So here we should get the instances of the Tetris in order they came from the peers here. So let's close this. No, we keep them both open. So let's make sure this is behaving as I expect. Tetris is not defined. Interesting. Oh, it was called sorted. There we go. So here we got 2 Tetris instances, and I am just gonna assume they are in the right order. Didn't fail at least. So where is our other window? Cool. So now we need to send this updated sorted array to the Tetris manager so it can sort this for us. So I'm gonna call this .Tetris manager.sort players. I'm gonna give it the sorted array. And then we go to the Tetris manager and we add the method sort players. And what could we call this? The Tetri. And this is quite simple actually. We can simply say Tetri.forEach Tetris. And we say this.document.body.append child Tetris.element. Because the way append child works, it never creates copies of nodes. So if we always put every Tetris last in order, we will sort them. See if the theory checks out, as we always should. There we go. Player 1 to the one here in the first window, and player 2 here in the second window. Let's throw in some more players to make sure our program works. Create this one here, another one, and another one. Okay, this is gonna be a little bit too many, but let's make sure we actually do the sorting correct. So here we have 4. I think that's enough actually. Here we say player 1, player 2 is bright, player 3 is bright, and player 4 is bright. You can see that they are controlling the correct one in every window. So I guess that's how we create the multiplayer Tetris using WebSockets.